Hello, distinguished viewers all over the world. Welcome once again to Simplified Maths Class. I am your host, Mr. Mike Omini, and today we bring to you bearing and distances part 2. Now, please, if you have not subscribed to our channel, kindly do that by hitting the red subscribe button, and God bless you as you do that. In our previous slide, we treated bearing and distances part 1. We went into the introductory part of bearing and distances. We talked about bearings, distances extensively, and then we brought out the two types of bearing scenario. The first one is by the use of the 3 digits, which we treated extensively, and the second one, which we are about to go into, is by the use of any 2 of the 4 cardinal points. Alright, so without waste of time, let's begin. Now, some bearings will be given using any 2 of the 4 cardinal points. And that will be, I gave instances, we can have N, 60 degrees east. Alright, now if we look at the 4 cardinal points, this is the north, south, east, and west. East this way, west. So we can have a bearing given in this direction. When we have in this direction, it means it is northeast. So the anchor point is the north. We begin from the north and read it towards either the east or the north towards the west. So we can have N, if this is 60 degrees and this is east, it means the bearing here is N, 60 degrees east. That's what we have. So that's the measurement. So we start from the north and go towards the eastern direction. That's how the bearing is measured. But let's say the bearing we are talking about is this way. Alright, so that can be, for instance, 50 degrees. This could be N, 50 degrees towards the western side. So that's N, 50 degrees the western side. So we are beginning from N to measure towards the west, which is N, 50 degrees west. Alright, and then we can also have from the southern side. Let's say we have a line here. So this line can be, assuming the angle here is 40 degrees. So this will be south 40 degrees towards the eastern side. Because we are starting from the south, we are measuring to the east. Alright? So if it is this way, let's say here. So let's say the angle is 45 degrees here. So this will be south 45 degrees towards the western side. So that's what we have. So this could be south 45 degrees towards the west. So if you look at all this, you can see that when you're measuring, when your angle falls in between north and east, it will be northeast, so not 60 degrees east. If it falls between south and east, it will be south 40 degrees east. If it falls between south and west, it will be south 45 degrees west. The angle can be anything. And then if it falls between north and west, if the angle you're talking about falls between north and west, we have N, 50 degrees west. And don't forget, please, we can convert these angles given to the 3 digits. You can be asked to convert angles in this format to 3 digits. Say for instance, if you have, watch me, if you have N, if you have the angle N 60 degrees east, N 60 degrees, N 60 degrees east. If you are converting to the 3 digits, just know that N 60 degrees east will remain at 60 degrees because you are moving this way now. We want to convert to 3 digits, so it means we'll be moving this way anti-clockwise. So any angle at this point will be N 60 degrees east will be equals to the 3 digits 0, 60 degrees. So using the 3 digits, it will be 0 because when we are using the 3 digits, we start our measurement from the north. So it means we are going this way. Alright, so since from the north to this point, 60 is 60, so it will still be 0, 60 degrees to 3 digits. But watch where we are here. Now if we have south 40 degrees east, so we have south 40 degrees east. We want to convert to 3 digits. South 40 degrees east. That means we want to turn and get to where this line is. That's what we want to do. We want to turn from the north and get to where that angle is. It means we are going to move from here this way. Watch. We are going to move from here this way and touch this line. That's what it means. We want to convert to 3 digits. Remember that this is S 40 degrees east, which is the angle from here to here, touching this line. So for us to convert to 3 digits, we are moving from the north to touch that very line we are talking about. And what angle will it be? Don't forget that if you move from the north straight to the south, it is 180 degrees. Alright? If you move from here straight to where we have this line, it is 180 degree angle on a straight line. So we are going to have 180 degrees minus, now we'll need to take out this in order to stop at this line. So we have to remove 40 degrees. So that will be 180 degrees minus 40 degrees. It therefore means that S 40 degrees east will be equals to 180 minus 40 will give us 140 degrees to 3 digits. So we have converted S 40 degrees east to 3 digits to become 140 degrees. Don't forget that. Now, assume we want to convert S 45 degrees west. S 45 degrees west to 3 digits. S 45 degrees west is this line, this way. Now, we want to convert it to 3 digits, meaning that we are going to move round from the northern pole round until we touch that very line. Until we touch that line. So what would that be in 3 digits? It simply means that it's going to be round here to here is 180 plus the 45 degrees. From here to here is angle on a straight line 180 plus the 45 degrees. So that will give us 180 plus 45 degrees. It therefore means that S 45 degrees west will be equals to 180 plus 45. That will be 225. So that will be 225 degrees. We've been able to convert it to 3 digits. It means S 45 degrees west to 3 digits is 225 degrees. Meaning that if we turn 225 degrees and touch this line, we've been able to make S 45 degrees west. S 45 degrees west. So we've been able to convert from the 2 cardinal points to the 3 digits. Now finally, we want to convert N 50 degrees west. N 50 degrees west to 3 digits. We want to convert it to 3 digits. So we are trying to see how to convert angles from here to 3 digits. Now to 3 digits means we are going to turn round from the northern pole clockwise to where we have that line. Have you seen? So we are turning to where we have that line. So for us to get this line, which is N 50 degrees west, we have to start from here to turn to convert it to 3 digits, touching that line. And remember that assuming I have completed the circle to the end, that would have been 360. So that would be 360 minus this 50 will give me touching this line. So that would be 360 degrees minus 50 degrees. So 360 minus 50 will give us 310 degrees. So we have been able to convert to 3 digits that N 50 degrees west will simply be 310 degrees. So this is how we can convert this to 3 digits. We've converted this to 3 digits. We've converted this to 3 digits. And we've converted this to 3 digits. Please take note of that. In an examination, you might be asked to convert these 4 cardinal points bearings using the 2 of the 4 cardinal points. You can be asked to convert it to 3 digits, to bearing in 3 digits. That's what you simply do. It means from the north, you turn around to touch where that line is supposed to be and you measure the angle. It's that simple, all right? Okay, so now we've been able to convert from the cardinal points to 3 digits. The next thing is to know when you're giving bearing about a point. How do you do that? Before I can give an example on a bearing that has to do with any 2 of the 4 cardinal points. Alright, so let's see how we can do that. Assuming you've been given that the bearing of A from B. Look at this. A question might come this way. It's very important. I was supposed to have shown you that in the last slide, but I have to show you now. Assuming you're told that the bearing of A, or let's say the bearing of A from B is 0.65 degrees. You can be asked to find what is the bearing. What is the bearing? What is the bearing of B from A? please, you need to understand this. They say the bearing of A from B is 065 degrees. From B, it means we are starting from here now, from B. This is B. So they say the bearing of A from which point? From point B is 065. So this is 065 degrees. So this is 065 degrees. It therefore means that this is where A will be. This is the point A. And of course, this is our northern pole. Now, you can now be asked, what is the bearing of B from A? So what is the bearing of this B starting from A? So they are asking us to find the bearing round this way, touching that very line. So what will this bearing be? It's simple, very simple. The bearing of A from B is 065. So this is 65 to A. We are measuring from B. Now they are asking us what is the bearing of this B now from A. That means we are measuring from A, which means we are turning from the North Pole to touch that very line. What will be the bearing? Already before now you're used to bearing as I taught you in the first slide. So if this is 65 degrees by alternate angles, this is also 65 degrees. This angle is alternate to this. But remember, what we are looking for is from here all to here. And that will simply be 065 degrees plus, from here to here is 065. But from here to here is 180. Angle on a straight line plus 180. So if you add 065 plus 180, 65 plus 180, you simply have 245. 245. So it therefore means that the bearing of B from the point A now is 245 degrees. Don't forget that. It's always the same thing. So anytime they give you the bearing of A from B is 40 degrees. What is the bearing of B from A? You map it out. You should be able to get it. Understand that the first one they gave is here. The bearing of A from the point B is 65 degrees. So it takes you to the point. You draw your cardinal point. What's the bearing of B from the point A? Meaning you will turn from the northern pole to touch that very line that took you to that particular place. And you can be able to measure it. Since this is 65, this is 65. Here is 180. So 180 plus 65 will give you the bearing you are looking for, which is 245 degrees. So we've been able to do that. It's that simple. A question can come that way. You should be able to do it. Now, finally, we are going into the second phase of the bearing we were left to do, which is using any two of the four cardinal points, which is what I explained previously, using north, south, east, and west. The one we had north 40 degrees east, north 30 degrees south, and so on. All right, so let's see how we can solve a problem, a bearing problem that is presented using any two of the four cardinal points. Let's take an illustration. Say, for instance, you can be given that the bearing of B, let's say from point A, is N 60 degrees east, and the bearing of, let's say, C from A is N 30 degrees west. Now, if line AB equals 50 kilometers and line AC equals, let's say, 40 kilometers. Calculate. Correct to the nearest kilometer. The distance between B and C. All right, so we want to see how we can find the bearing, assuming it is coded using any two of the four cardinal points. as we have explained before now. So let's bring out the triangle we are talking about. They say the bearing of B from the point A is n 60 degrees east. Alright, so let's say this is point A. This is point A. So this is north. Remember that this is east, this is west, and of course this is the south. Don't forget, that's the south. So our point A is somewhere. Let's say this is point A. Now they say the bearing of B from A, where you are taking from is where you're measuring from. Alright, so from A, the bearing of B is n 60 degrees east. N east, that's 60 degrees. I take it this way. So that's n 60 degrees east. So that's n 60 degrees east. We have that already. And remember, we are saying the bearing of what? B from A. It therefore means that this town here now will be town B. This is our town B. And of course, this is still the northern pole. And of course, this is south, east, and west. Alright. Now, they now said, and the bearing of C from A is n 30 degrees west. The bearing of C from A n 30 degrees west, not west. So we are taking 30 degrees here. Alright, so let's take that as 30 degrees. Let me make it straight. So let's take, okay, that's straight enough. Alright, so we are going to have this. Okay. So this is what we have. So this is our north, south, east, and west. So they said, and the bearing of what? The bearing of C from A. This is from A. We are taking C. Alright, so this point C. They said it's n 30 degrees. So it means that here is 30 degrees. So this point here is 30 degrees. So we have n 30 degrees towards where? Towards west. So this is the angle we are talking about, 30 degrees. Now, let's join the 2 points together. So when we join the 2 points together, it gives us a triangle. But note that they have said AB is 50 kilometers. AB. So here is 50 kilometers. That's why it is longer. And then they now say the AC. AC is 40 kilometers. Here is 40 kilometers. That's why it's shorter. You can see 40 is shorter, but 50 is longer. So what they want us to find, they say we should calculate correct to the nearest kilometer the distance between B and C. From B to C. B to C. So this is where they want us to find. So this is capital A, this place is small a. So the distance B to C is small a. Don't forget that. And of course, if this is C, capital C, this side is the small c. And if this is capital B, this side is the small b. Don't forget that. We did all this in the use of sine and cosine rule, and we did this in the first slide, bearing and distances part 1. So now they want us to find the distance between B and C. Now observe something. If you look into the triangle, you see that 60 degrees plus 30 degrees gives us 90 degrees. It gives us 90 degrees. It therefore means that this triangle is a right angle triangle. So there will be no need for us to use the sine or the cosine rule. Alright? Rather we will use what? For us given two sides, we are looking for one side. We can use Pythagoras theorem. That's why I told you in some rare cases, you can actually use Pythagoras theorem or SOHCAHTOA to solve problems that involve bearing and distances in rare cases. And it has happened in this case. But understand that even if I use Pythagoras theorem, because the triangle is right angle. Why? Because this angle is 90 degrees, it's a right angle. I can use Pythagoras theorem to find the side I'm looking for, A. I can also use cosine rule if I feel like. Why? Because I have side, and included angle. So even if I use cosine rule, I'll still have the same answer as using Pythagoras theorem. Let's see if we can prove that fact. Okay, now we have a right angle triangle which is 90 degrees, and we are looking for this side, small a. Let's see, by Pythagoras, why Pythagoras? Because it's a right angle triangle. Alright, so the side we are looking for, a squared, will be equal to, this side is the longest side. By Pythagoras, we have said that the longest side, which is hypotenuse, the square of the hypotenuse is the sum of the squares of the other two sides. The sum of the squares of the other two sides. And the other two sides are definitely adjacent and what? Opposite. That's what we did. If you have not studied our slide on Pythagoras theorem, search through all the videos. You will see the slide on Pythagoras theorem. You can actually learn it. So we can now have the hypotenuse is the longest side. How do you know that A is the longest side? The longest side is always the side that faces the 90 degrees. That's the longest side. So A is the longest side. It faces 90 degrees. So that longest side becomes the hypotenuse. So that's the A. So our A squared will be equals to the sum of the squares of the other two sides. So we can use 40 squared plus 50 squared. So our A squared will be equals to 40 squared will be 1600, and then 50 squared 2500. So our A squared will be equals to 16,000 plus 25,000. All right, so we have 1,600, 1,006 plus 2,500. So we have 4,100. So our A now will be the square root of 4,100, and that will give us our A. All right, so we have the square root of 4,100, and that gives us 64.03. And they said we should find correct to the nearest kilometer. So to the nearest whole number, our A will be 64 kilometers. Now you can now say therefore the distance from B to C, the distance from B to C, which is the A, is equals to 64 kilometers to the nearest kilometer. All right, and you can agree with me that this side is actually the longest side, as I said earlier on. Here is 40 kilometers, this side is 50 kilometers, and we have computed this side to be 64 kilometers. It therefore means that this side is longer than these two sides. And I've always told you, wherever you have 90 degrees, the side opposite is the longest side, and that's the hypotenuse, which is the side always directly opposite the 90 degrees. Is the hypotenuse. It's always the longest side. So when you calculate such side, you should have your answer being larger than the other two sides given. So we have been able to solve that using Pythagoras. But of course, like I said, you can also use the cosine rule to solve this. Why? Because we have side, and included angle. If you use cosine rule using 90 degrees here, you will still have this answer 64 kilometers. Well, for the benefit of doubt, I would like to show you that. For the benefit of that. But remember that the cosine rule is used only when the triangle is not right angle triangle. So by concept, it is actually wrong to use the cosine rule when you have 90 degrees. But I can assure you that even if you use the cosine rule when you have 90 degrees, it won't alter your answer. By concept, you are wrong, but your answer will still be the same. Why are you wrong by concept? Because you are not supposed to use cosine rule for right angle triangle. You're supposed to use cosine rule when the triangle is not right angle. But by calculation, you can actually have your answer. So under exam condition, whoever uses Pythagoras theorem will score a higher mark than the person who is using cosine rule. Why? Because the person using Pythagoras theorem is obeying the rule that Pythagoras theorem is used for solving right angle triangles. But like I said, you can apply cosine rule and have the same answer. Why is it so? Let me show you that. Let me actually show you that. Assuming you have to apply cosine rule, you will be having this. You'll be having A squared, which is what we are looking for, will be equals to B squared plus C squared minus 2BC, the cos angle of A. That's what you will use, because we have side, and included angle. Watch and see why it will still give the same answer. So our A squared, which is what we are looking for, will be equals to B squared, that's 40 squared, plus C squared, that's 50 squared, minus 2 times our B, which is 40, times our C, which is 50. And then the cos angle of A. The angle at A is 90 degrees. Please watch why we still have the same answer. So our A squared will be equal to 40 squared, 1600, plus 50 squared, 2500, minus 2 times 40 times 50. Watch. 2 times 40 times 50 will give us 4,000. 4,000. Then the cos angle of 90 degrees automatically gives you 0. When you press cos 90 degrees in your calculator, what you have is 0. So you still have A squared to be equals to, if you add this to this, if you add 1,600 plus 2,500, you will have, I'm coming 1,600 plus 2,500, you're going to have 4,100. Please watch me. Minus 4,000 times 0 will give us 0. Alright, so that our a squared will be, this minus 0 will still give us 4,100. And then a will now be the square root of 4,100, and which you still have the square root of 4,100, square root of that. You will still have the answer we had before, which is 64. So you still have that same answer. That's why I said, even if you apply cosine rule, because you have side included angle, assuming you made a mistake and applied cosine rule, you will have the same answer with somebody who used Pythagoras theorem. But the person who used Pythagoras theorem by concept is more correct, will score a higher mark. But you that use cosine rule, you actually have the same answer, but by concept you are wrong, because the cosine rule is only used when the triangle is not right angle, and Pythagoras theorem is used when the triangle is right angle. And in this case, the triangle is right angle because 60 plus 30 is 90 degrees, and so by right you're supposed to use Pythagoras theorem. But I've proven to you that the two will give the same answer. Thank you very much for watching my slide, bearing and distances part 2. Until we meet next, I still remain your host, Mr. Mike Omini. If you enjoyed my class, don't forget to give me a thumbnail and then give me a comment in the comment section. If you have any question whatsoever, give me a comment in the comment section. I will respond to that your question. And don't forget, if you have not subscribed to my channel, it will do you good to actually hit the red subscribe button. God bless you. See you next Simplified Maths class. It is. Cheers.